Okay, so remember this one, you choose correctly, it can largest area, but the key is work done by the gas. Means expansion.
I mean A and B is the same what some
A
more.
and B cannot be area too small. So it's C
And both of them are the same.
This one is compression is larger. Net work done by compression. So that's why answer is donkey. Let's go to number 8.
You mean expansion is larger, right?
Expansion is larger. The molar heat capacity at constant pressure CPM. If R is a molar gas constant, which expression represents the number degree of freedom of the gas? This one you got no choice. You have to memorize the formula. If you don't if you know CPM formula, go ahead. If not, work with CMV. Right? For me, I don't like to memorize too many formula because so many how to memorize. Right?
Too much.
This one, and then this one, and put in and derive it. You can derive this formula or memorize it if you want to. Which one you prefer? And then you want degree of freedom, F. Okay. Take your R across there, you get CMP minus that. Then you take the 2 up, get the 2, then take the R down, you get F. Can?
Can.
The answer is C. Maths only this one.
All of this is just derivation.
Just using the formula and get what you want. Play with the formula, that's all.
Oh, okay. Is number 9 donkey, sir? Answer. I think I found the answer.
Heated at constant pressure, if the increase in volume is that, and the increase in energy is that, what is the heat energy absorbed? Yeah, just use the first law. There's a first law. There's a calculation for constant pressure, work done. And put it in there. You are told increase in energy, so correct 100. Then P is 10 to the power 5. This one change it to meter and simplify. Donkey, correct? Yeah.
Okay, I got it correct, sir.
Yep. Next one.
Okay, number 10.
Isothermal curve of a fixed mass of ideal gas which undergoes changes SQ, QR shown in the PV below. Which statement describes the changes correctly? Heat is supplied to the gas in QR. Right? Remember, this is lower temperature, this is higher temperature. So no work done. So if you're going to move to higher temperature, heat must be supplied. Right? So QR, higher temperature to lower temperature. Remember, Q is higher temperature, R is lower temperature. You can use your first law. Internal energy decrease, you put a minus sign there. This work done on the gas, you put a minus sign there. Right? So negative means heat must be flowing out, not going in. It's a cooling, if you like. Cooling. Heat must flow out.
So the answer is donkey.
And SQ.
Correct.
SQ.
A doesn't make sense, A doesn't make sense because QR is compression, so cannot.
Okay,
it's not supplying it.
Your work done. SQ, no work done.
Yeah.
No work done. There's no change in volume.
B is also wrong.
C is false.
Yeah.
C are told that.
So the only answer is donkey. Cannot.
Energy of the gas in the whole process increases. Cannot be. Right? Because
SQ yes, but
S
QR
and
no.
R are the same
So
temperature. Yeah, you're right. Your argument is correct. S and R same temperature. If at Q there's an increase in internal energy, at R and S same energy, so there's no increase in internal energy. The SQ, work it out. SQ, no work done. So there, the heat supply must go to increase the internal energy. Donkey.
Yeah, the only thing perfect one is donkey.
Okay, good. Next one.
Oh, now I can understand the thing, sir.
Good, no? That's why I say it must work. It must work.
So 1 minute. Okay, you can go next one, sir.
Okay, what's the answer? The monoatomic ideal gas is initially at pressure P0 and volume V0. That's the initial part there. P0, V0 here. The gas is cooled at a constant volume until its pressure is
Until
half.
the pressure is halved.
This one, correct. The gas is then compressed adiabatically until its volume is half. If the value of gamma is 5/3, which graph shows the variation of pressure with volume V for the gas? Yep.
Yeah, this one they say at PO and VO, right? So PO, VO means they say until it's halved. So pressure is halved.
Yep. What's the answer? Yep. What's the answer?
Answer is boy.
No. The graph should be steeper, so it can be gas at A. Right? If you are at V0 and pressure half that, so if you decrease the volume, the pressure must go up. So if we look at this point at B, this isothermal change. Right? Isothermal change, PV is constant. Okay now. You decrease the pressure, you decrease the volume, the pressure increases. Directly proportional. So it's inversely proportional. So it's isothermal change. So it means that it cannot be C. C is lower than that. So it must be A because it is steeper. Right? If you want to
I see, I'm
calculate, you can
almost
calculate
close.
out. Not necessary that too technical lah. You can guess it out. This is isothermal. So diabetic is steeper. This one. Yeah. Can either way, you can calculate out if you want to. Yes, no, yes, no.
Okay, sir. Got it.
Either by
But I
calculation
don't
or
understand why is it A? Then why about the 5/3 then?
C cannot. See, you see, you must be able to read the graph. B is isothermal change. Right? B V0 times half V0 is half V0 V0 and then half V0. Right? For this point there, half V0 times V0 is the same. So this is isothermal change, this one. So adiabatic is deeper. That's all. That's the reason why I've been asking you to do your homework. Try the question there, you can understand. Okay?
Okay.
Adiabatic, the graph is steeper. Okay now. If not, work it out.
Okay.
Work it out this way. Use the formula to work it out. A bit longer, taking more time as well. Okay, what's the answer for number 12? Diatomic at initial pressure V0, volume V0 is compressed adiabatically until its volume is that. The gas is then expanded isothermally back to the initial volume V0. What is the final pressure of the gas? That one you have to work it out. Can? Either you memorize gamma for diatomic or work it out. Memorize or work it out. Use the formula to work it out. Then work the first part. Initial pressure, initial volume. There's a final volume. So work it out. Final pressure after the adiabatic process. Take L1 across V2 down. P1, then put in your value. Right, copy out. Then after that, you have to is isothermal. Okay. So isothermal, you can use PV equals constant. So P2, V2 over V3. So V2 is just that one there. V2 is that. And then you are told that the volume finally is V0. Right? So what is the final pressure? Calculate out. Answer is C. Can?
Can. Okay.
Section B.
Very rare.
Very rare. But just come out.
But confirm chapter 9, 10, 11, like section B and C will definitely come out once. That one I confirm.
But either one will come out lah. Right? But the most common is
that's why 9, 10, 11
isothermal
is most
and
important.
adiabatic. What's the basic principle used in the first law of thermodynamics? Right? Principle of conservation of energy. An insulated cylinder is fitted with a frictionless light piston which contains there's a number of moles, 0.22 mole of diatomic ideal gas. The gas expands from the initial volume, final volume with the initial pressure. Name the thermodynamic process. What process is this one? Yep. Yep. What is the process? Isothermal or adiabatic?
Isothermal or adiabatic? Adiabatic?
Yeah. Is it insulated? Insulated, no heat loss or gain. Right? Adiabatic process. Calculate the final pressure of the gas. Okay, as I said, memorize the diatomic gas, the gamma, if not calculate out. Okay, calculate out. You need to remember your formula, the ratio, and put in your value. The atomic F is 5, and is 7, 1.4. Use the adiabatic formula. Okay, you want P2, take your V2 down and put in your value. There's your initial pressure. Then your initial volume. There's your final volume. 10 to the power 1.4. Work it out. Can?
Can. 1.88 times 10 to the negative 10 to the power 5 PA, right?
Yep. PA.
Okay.
To put your unit.
Okay.
An insulated cylinder. Okay, we've done that. Calculate the work done by the gas. So that is your final pressure. So you have to memorize the formula for a diabatic process work done. No need to derive it. They didn't ask to derive it, memorize it. There's a formula, put in your value and calculate out. I'm not sure why they get 5. I get 26 joule. You can work it out.
Okay.
But you have to memorize the formula. Okay.
Just a minute, sir. Okay.
Okay. Let me just go step by step with you. Okay, number 2. Deduce from the first law of thermodynamics the change in internal energy of a gas after undergoing a diabatic process. So to write the formula down for a diabatic process, tell them what is it. No heat enters or leaves the system, that means Q is 0. Use the first law. Q is 0. So you can either get minus U equals to W. In this case, work done by the system, the internal energy decreases. Right? If you want to expand, the energy must decrease. Or you can also write as delta U equals to minus W. Work done, in this case, minus is work done on the system. Right? Increase the internal energy. Either one. Can?
Yeah, can, sir.
Okay. For a diabetic, your given gamma is 1.4. Initially, temperature is 270. Volume is that. Pressure is that. Undergoes a diabetic expansion to a volume that determine the final temperature of the gas. Memorize formula, that formula, a diabetic formula, temperature and volume. Okay, the one final temperature is T2, that is the initial, is the final. So take your
So what formula is said is there again? Adiabatic formula.
adiabatic formula, this one. TV gamma
Okay.
minus 1 is a constant. You have to memorize. Then it just pass only. Okay.
Uh,
Yep. Anything not clear?
no, all okay. All
Okay.
right.
Let's go to part 2 then. For diabetic gas, given work done. We have to calculate the final pressure first before we can calculate work done. Okay, so we can use this formula. And then we want to find P2. Take the T2 across, take the V2 down. That's what we get. Then put in your value. Right? There's your initial pressure. Change it to 10 to the power 3 is kilo. Then initial volume. That's the initial volume. That's the final volume. And then your T2. T2 we have already calculated out. Right? There's your T2. Right? T1 is 250. Put inside that and calculate. And memorize the formula again. The formula for a diabetic, work done. Okay.
That's the whole formula, cha.
Now, the work done for a diabetic process.
Oh my god, just for 2 marks.
Okay, got 2 marks.
So that's, yeah, that's 2 marks, sir.
2 marks, eh? 2 marks is for the other one.
Which one? No. There's actually like two, you know, it's separated.
Check your
You
book.
did for the other one already. This one is another one. You did for the
3
previous
mark,
one
not
already.
2 mark. 3 mark.
3 mark. Oh, okay, then okay.
3 mark. Okay.
Okay.
So you want to carry on, or you want to carry on tomorrow?
Tomorrow lah, sir.
Okay, we can try the rest. We'll do it tomorrow. Then we'll stop here.
Sure. Go back again. Okay, thank you, sir.
Okay, see you tomorrow 9 o'clock.
See you tomorrow 9 o'clock. Okay, thank you, sir. I want to have extra class, sir. Monday.
Monday,
Hmm.
one extra class can. What time?
I'll tell you lah, sir. Maybe morning can lah, sir.
Okay, you let me know.
Okay. Thank you, sir.